Unit 3B, Lesson 4. In this lesson, we're going to start out reviewing how to factor quadratic functions. Then we're going to go through the process of completing the square to solve quadratic equations. We're also going to use completing the square to rewrite quadratic functions in vertex form. When going through completing the square, we're going to get a little help from T Swift when adding the blank space to both sides of the equation. And alright, b over 2 squared. For the first example, we're going to solve the quadratic by factoring. If we're going to use the factoring method, we want to set the quadratic equal to 0. So first we would add 32 to the other side of the equation, leaving us with x squared plus 12x plus 32 equal to 0. Now we're looking for factors of 32 that when we add together give us 12. And I forgot my x there. So if I list my factors of 32, I have 2 and 16 and 4 and 8. There might be some other ones, but that's all I could think of. I'm looking for the combination that when you add these two factors together, you get a positive 12, which would be 4 and 8. So we can factor this into x plus 4 times x plus 8. Zero product property tells us that we can set each of these factors equal to 0 to solve for x. So if I set x plus 4 equal to 0, we get x equals negative 4. If I set x plus 8 equal to 0, we get x equals negative 8. So negative 4 and negative 8 are two solutions to this quadratic equation. Now a second example, we want to solve this quadratic equation, again using the factoring method. This one's going to be a little more difficult because we have to find factors of our a value, which is 2, as well as factors of c, negative 12. So to start out, let's list our factors of 2 and negative 12. At this point, it becomes a little bit of guess and check after you list your factors. You're looking for the combination that when you multiply two of the factors together and add them, the sum is equal to 5. Well, if I take 1 times negative 3 plus 2 times 4, we have negative 3 plus 8, which gives us 5. So I know I have to use the combination of 1 and 2 and negative 3 and 4 when factoring this quadratic out. Now when putting this in factored form, 1 and 2 are going to be the coefficients in front of my x terms, so I have a 1x and a 2x. We multiplied the 1 by negative 3, so when putting this in factored form, if my 1x is here, the negative 3 has to be in the opposite parenthesis. Think about the FOIL method. When we multiply the outside terms, we're multiplying 1x times negative 3. The 2 corresponded, went with the 4, so if the 2x was here, my 4 would have to be in the opposite parenthesis. Again, now at this point, we would use the zero product property, set each of these factors equal to 0. When we set each of these factors equal to 0, we get x equals negative 4 and x equals 3/2. Now in the next few examples, we're going to use the process of completing the square. When completing the square, there's two main things we have to make sure are true. Our a value, the value multiplied in front of x squared, has to be 1. And we want to isolate all of our x terms on one side of the equation and our constant on the other. So to start this problem, we first have to divide this whole equation by 2 to make our coefficient in front of x squared equal to 1. And then we're going to have to subtract our constant to the other side. So if we divide the whole equation by 2 and then subtract 13/2 to the other side, we're going to be left with x squared minus 3x on one side of the equation and negative 13/2 on the other side. I left a space here because when completing the square, now we're going to get some help from T Swift and add a blank space to both sides of the equation. The value we're going to add is going to be our b value, which is the value multiplied in front of x, which is negative 3. Divide that by 2, and then square that quantity. If we add that to the left side, we have to add that same quantity to the right side of the equation to keep it balanced. So when completing the square, the value you add is b over 2, that quantity squared. The reason we add b over 2 quantity squared is because on the left side of our equation, if we add that value, it's going to create a perfect square trinomial, meaning it's going to create something that we can factor into a binomial multiplied by itself. So once we add that value, you know it's going to be some binomial squared equal to negative 13 over 2 plus, now if we would square this out, negative 3 squared is 9 over 2 squared is 4. So when trying to figure out how this factors down, if we have an x squared, this is always going to be an x, and then we simply have to put our b over 2 value. So we would have x minus 3 over 2. When trying to determine the sign, if our b value to start was negative, this will be negative. If our b value to start was positive, this will be a positive. So we factored this down into x minus 3 halves, that quantity squared on the left side, equal to negative 13 over 2 plus 9 fourths. Now on the right side, since we just have two constants being added, we could add those together by getting a common denominator. Our common denominator in this case would be 4, so we could rewrite this as negative 26 over 4 plus 9 over 4, which simplifies to negative 17 over 4. Now we have to go through and solve to get x isolated by itself. So if this is a quantity squared on the left side of the equation, we would have to take the square root of both sides. When we do that, the square root and the squared cancel out, leaving us with x minus 3 halves equal to plus or minus radical negative 17 over radical 4. Remember, when we're having square root properties, if we're taking the square root of a fraction, we can break that up into the square root of the numerator divided by the square root of the denominator. And also, when we're taking the square root of a variable squared, we have to account for the positive and the negative result. The last step to get x isolated by itself, if we're subtracting 3 halves, we would have to add 3 halves to the other side of the equation, leaving us with x equals 3 halves plus or minus. If this is a negative underneath the radical, think back to complex numbers at the beginning of the year. We can take a value of I out because I is the square root of negative 1. So we would rewrite this as I times radical 17. And then in the denominator, the square root of 4 is 2. And this would be our final answer. We have x equals 3 halves plus or minus I times radical 17 over 2. One thing I recommend you do when going through the process of completing the square is always leave your b over 2 value in factored form. Okay, if you leave that in factored form throughout, when you're trying to combine fractions later on, it's just going to be easier rather than having decimals and fractions mixed up. The last example, we're going to convert an equation that's written in standard form into vertex form, just so it's easier to identify the vertex of our graph. We're going to use the process of completing the square when converting it into vertex form. The only difference in this case is instead of adding that b over 2 quantity squared to each side of the equation, we're going to add that quantity to the right side as well as subtract it later on. So if we're in this form, y equals x squared plus 7x minus 8, we're going to separate our x terms and our constant term. So if we separate our x terms from our constant, we have x squared plus 7x plus, we're going to add our b over 2 value, which is going to be 7 over 2. If we add that value, at some point we have to subtract it to keep it balanced, so we're going to subtract 7 over 2, that quantity squared, at the end. Now here, we added that b over 2 quantity squared value to create a perfect square trinomial. So if we're going to factor this down, if we have an x squared, it's going to be an x. Our b value is positive, so we know this is going to be positive. And then we add b over 2, 7 over 2, that quantity squared. And then we subtract 8, and we have minus 7 squared is 49 over 2 squared, which is 4. The last thing we need to do is get a common denominator, which is going to be 4, and combine those fractions. So if we combine those two constants at the end, we get y equals the quantity x plus 7 over 2 squared minus 81 over 4. So now we have used completing the square to write this in vertex form. To identify the vertex, we basically set what's in our parentheses equal to 0 and solve for x. So it would be the opposite of positive 7 halves. So we have negative 7 halves, and then our k value at the end, negative 81 over 4. This would be the location, the ordered pair of the vertex to this quadratic if we graphed it.